No, I am not joking. This is very real. So yes, today we are discussing the black hole bomb and how to make use of it. Buckle up. And yes, black holes spin a lot. First of all, why do they spin? This is due to something called angular momentum. To put it simply, if an object is spinning, to put it simply, if an object is spinning, it doesn't want to stop spinning. That's essentially Newton's third law of motion. An object in motion will stay in motion, or an object in rest will stay at rest unless acted upon by an external force. Oh wait, sorry, our first law of motion. But yeah, basically, if an object is spinning, it will not want to stop spinning. And what angular momentum says is that if the object's radius gets smaller, then the object spins faster. So the smaller something gets, the faster it spins. So a spinning black hole can spin millions of times a second at the slowest. That's because of how small they are. And here's something else.
Just 1 minute. Let me just note everything down. Yes, so continue. Sure. It's okay.
So black holes have a singularity, stationary ones have a singularity, but by definition, a point, like I discussed, cannot spin. If you remember a previous class, I mentioned how a singularity is just a point with the mass of everything in the black hole. But it cannot spin because it's a point. Yet spinning black holes spin. So we got a ringularity instead. This is a ring with no surface or thickness, but it has a shape of a really small ring, very small ring, and it's got all the mass of the black hole. So a ring plus a singularity equals a ringularity.
Okay, wait, can you explain the ring thing again?
Just think a singularity, but a ring because spinning. There is no real logic to this, but that's the simple explanation for it. It's just a singularity that spins, but because it's a point and a point cannot spin, it turns into a ring.
Okay, yeah.
Just don't try and logic this. Yeah, there is actually a new region of reality around these black holes because they're the same as a normal black hole, but they're spinning. So they have the same gravitational pull as a black hole. And because they spin, it's so incredibly powerful. Space-time itself is dragged with the black hole. You create this entirely new region of space-time called the Ergosphere. Here's a simple way to put it. You fall into a normal black hole, it's sliding down a hole. Falling into a spinning black hole is like falling into a whirlpool, because the moment you enter the Ergosphere, you are dragged along in its spin. Okay, you are spun round and round and round before you get to the center. The spinning part of the whirlpool is the Ergosphere, and the center is the black hole. Now, because the Ergosphere is affected by the black hole's gravitational pull.
Excuse me?
Yeah.
So you said falling into a spinning black hole is like a whirlpool. So can you just express it? I don't understand.
Okay, so a whirlpool, basically, what it is, it's like how to put this? So you know how when you turn your tap, you know how like when you drain your bathtub, the water seems to spin around before going into the drain?
Yeah.
That's what a whirlpool is. Anything in the whirlpool will be spun around in the spinning area before it goes into the drain.
Okay.
Does that make sense?
Yeah.
Yeah. And as it says here, in order to be standing still in the ergosphere, you have to be moving faster than light because that's how powerful the gravitational pull is. So in short, impossible. Oh, and one more
1
thing,
minute, just
you
like
don't
I
need
didn't
the spelling of
understand like about this thing. I did not understand about the falling into a whirlpool thingy.
Does everyone know what a whirlpool is before we go on?
Yeah.
See, look, when you fall in, like if you were in a whirlpool, you are going to be spun around by the whirlpool before you get to the center.
Yeah.
The ergosphere is the spinning part of the whirlpool, and once you get to the center, that's the black hole itself.
Okay.
Does that make sense?
Yeah.
So yeah, that's how it works. Does that make sense to you?
Yeah.
Yeah, and one more thing, it's actually possible to exit the ergosphere. This is an important point, so remember this. You can leave the ergosphere, but you can't leave the black hole.
Wait.
So if you were to
Wait,
enter
you can leave the ergosphere, but you cannot leave the black hole.
if you fall into the black hole, you're trapped there forever. If you fall into the ergosphere, you can escape it.
Okay, just let me note that down.
You don't need to note that down, don't worry. You need to note the spelling down. That's all I'm gonna say.
Yeah, I'm noting the spelling down just to remember. In the test, I'm gonna close it.
Everyone cannot use it in the test.
Yeah, I won't see it. I'll keep it aside.
I know. If I figure out if I think anyone's using it, they don't get the point. That simple.
Okay.
I have a question. So it says that in order to be in the ergosphere, you have to be moving faster than light. So it says it's basically impossible. So then how can you escape it if it's impossible?
No, see, look. This is one of the weird things about reality, to put it simply. See, look. What I'm saying here is, if you want to stand still, like completely motionless in the ergosphere, you have to be moving faster than light. But you don't have to be moving that fast in order to escape it.
Okay.
Because escaping it and standing still in it are two different things. Are you confused still?
Makes a little bit sense now.
It will make a little more sense once we move on. But
if you stand in the ergosphere, you have to be faster than light. You have to
if you
move
want to
faster than light.
stand still, if you want to stand still in the ergosphere, you have to be moving faster than light.
Okay.
If you want to stay in the ergosphere at all, you don't need to be. Here's why. I'm just going to move on now. See, look, the ergosphere gives the black hole's kinetic energy to whatever's inside it. To put it simply, if you're moving in the same direction as the ergosphere spin, you are going to go as fast as the black hole spins. And
wait, so I didn't get that actually. Can you repeat that about standing in the same direction?
see, look, if you see my pointer, right?
Yeah.
So this region here where it looks like everything is spinning, that's the ergosphere. Okay.
Okay.
And it looks like it's spinning in this way, counterclockwise, right?
Hmm.
Now, if you were to enter the ergosphere and you were to go in this direction, you would be going as fast as a black hole is spinning.
Okay.
So incredibly, incredibly fast. You see, if you look at this little GIF here, you can see that the object first moves in this direction over here. Look, once it enters the ergosphere, it's dragged in this direction, and it's getting faster and faster because it's gaining all of the kinetic energy of the black hole itself.
Okay, wait. Okay, 1 minute.
And because the black hole spins faster than light, it's impossible to stand still. But more importantly, you will be able to go nearly as fast, if not faster than light, if you're able to leave the ergosphere in the direction of its spin. It's a little confusing, but how do I put this? Okay, so going back to the whirlpool analogy, let's imagine a very big whirlpool you can spin it. Okay. So everyone just imagine that. So in a very big whirlpool, if you were to swim in the direction opposite to the whirlpool spin, you won't be able to go anywhere, right? It'll be very hard to go anywhere, right?
Yeah.
But if you were to go in the direction the whirlpool spins in, you can go much faster, right?
Yeah.
That's what I mean.
Yeah. Okay.
And just before we go on, does everyone know what kinetic energy means?
I think so, yeah.
To
No.
put it simply, the energy of motion, the energy you give while moving. It's that simple. Okay, let's move on. You can actually steal this energy from the black hole. Here's how we do it. You can either steal kinetic energy, aka you can move faster, or you can steal light energy from the black hole. And that light energy can also turn the black hole into a bomb. But first, let's talk about stealing kinetic energy. Yeah, this is similar to Star Wars.
So I didn't understand what you said.
Could you repeat if you had a question?
Can you repeat what you said because I couldn't hear you.
Okay, so there are two things we can steal from the black hole: kinetic energy, or we can increase our speed without wasting any of our resources. So like, you know how a rocket has rocket fuel? So normally when you fire rocket fuel, you have to waste all of its energy. You have to waste all of the fuel to get to a certain speed. But if you were to use a rocket in the Ergosphere, you wouldn't need to use the rocket fuel for the same amount of energy. It'll make sense later. Hang on.
Steal kinetic energy and
Light energy.
okay. Yeah.
So first of all, let's talk about stealing kinetic energy. How do we do it? This is very simple. You travel into the Ergosphere in the same direction as its spin. Once you get in there and are at maximum speed, like look at this diagram here, you just eject something into the black hole. You just need to give yourself a little kick to escape the gravitational pull of the Ergosphere and the black hole. Newton's third law of motion. Every action has an equal and opposite reaction. And in space, there's nothing to slow us down. So in space, if you were to throw something in the opposite direction, you yourself, like if you were to throw something forwards, you go backwards a little. Does that make sense?
Yeah.
Because see, look, the reason why that doesn't happen in Earth is because there's a lot of things resisting us, whereas in space, there's nothing to prevent us from doing that. So if you were to throw a water bottle in one direction, you would move slightly backwards in the other direction.
Can you repeat how we can steal in the kinetic energy?
It's pretty simple. You travel into the Ergosphere in the same direction as it spins. So this way, in this case, clockwise. And then once you're inside and you've achieved maximum speed, you throw something into the black hole so that you can escape the Ergosphere. So that once you leave it, you have all of its speed. Okay. Does that make sense?
Yeah.
Now here's something important. The black hole will lose energy in this case. The black hole will spin a little slower after this because it gives energy to whatever you're traveling in, let's say a rocket. If you were to throw some parts of your rocket into the black hole, then the part of the rocket that still remains, that exits at much higher speed with some energy from the black hole. The black hole can't recover that energy, and thus it slows down a little. Does this make sense?
Yeah. So it's called Penrose process.
Yeah, it's named the Penrose process. Now, the thing is, don't worry about making the black hole like die. This will last forever just because of how much energy a black hole has. So yeah, note this down. Penrose process, very important.
I noted it down.
Okay, does anyone have any questions on this slide? I'm gonna assume that's a no.
Yeah, okay, wait. Like when we throw this thing into the like the black hole, like what happens? I didn't understand that part.
You throw something into the black hole, you lose that forever, but you can escape the ergosphere. Because in space, if you throw something in the opposite direction, like if you were to throw something forward in space, you go backwards slightly. You throw something to the right, you go left slightly, and so on.
Wait,
Okay.
but like if we throw it inside the black hole, you said you'll go back slightly, but we won't escape the ergosphere. How will we do that?
No, because you will escape the ergosphere because think about it this way. If this is a rocket, that's a lot of mass you're throwing into the black hole. That gives you a very big kick, and that will send you flying this way out of the ergosphere. Okay.
Thank you.
So it's based on mass, but let me put it this way. If I was to push something that weighed the same as I did in the opposite direction to me in space, like if I was to push something forwards that weighed the same as I did, me and the object move at the same speed. Something that weighs less than I do, I throw that, it moves much faster than I do because it weighs less. Something that weighs more, I move faster because it weighs more. Does this make sense?
Makes sense.
So yeah. Anyway, how is this useful? It's basically its only use right now is just traveling the galaxy. It just makes space exploration very easy. So we can visit this galaxy far, far away. Everyone knows what quote this is, right?
What?
Everyone knows which movie this is from, right?
No.
Go watch Star Wars. Anyway, the bomb. This is how we steal light energy from the black hole. And honestly, it's very simple. We can do it. It's actually possible within our current technological prowess. Like with our current technology, we can do this. We just need to make a lot of mirrors, and we're very good at that. All we need to do is we need to surround the black hole and the ergosphere in mirrors, open a small window in it, and fire a beam of microwaves. I don't mean the kitchen thing. I don't mean the thing you put your food in and heat it up with. I mean microwaves here. Where is it? Here. This is a type of electromagnetic radiation. It's just a form of light, basically. You just need to fire a form of light into the ergosphere, and then you just close off that hole. Now, as they go through the ergosphere, they gain kinetic energy because it's moving, right? They gain some energy, but that's immediately turned into light energy. So the microwaves become more intense. They become more powerful. Then they bounce off a mirror, and it goes through the ergosphere again, repeating the process. Okay. Does everyone understand that?
Yeah.
I didn't understand.
See, look, if you have let's say you have the mirror, the shiny part of the mirror pointing towards the black hole, you fire a form of light into the black hole, then it will bounce off the mirror and go through the ergosphere again. Once it goes through the ergosphere, it gains some energy, bounces off the mirror, gains some more energy, bounces off another mirror, and then repeat over and over and over again.
Yeah, but then how do we get that energy? How do we catch it?
I'm going to explain that, but first of all, what you need to know is super radiant scattering.
Okay, 1 minute. Let me write that down.
That you definitely need to know the spelling of. But yeah, this is very fancy science speak. That basically means that the microwaves bounce between the black hole and mirrors, and they just become they gain a lot of energy.
Yeah, I noted it down.
Yeah, so how do we gain this energy? It's really simple. I mean, we can, if the mirrors do not have any gaps in them, then the energy will just build up until it has nowhere to go, and it will, then the amount of energy there will be so powerful that the black hole itself explodes. We get a powerful bomb. If we open small gaps in the mirrors, then some light can seep outside and into like the universe. And if we have a space colony built around it, we can have like a home that can last for trillions of years. Because black holes last for so long that if you have gaps in the structure, small gaps, like not very big gaps, maybe at most 10 centimeters, 10 centimeter gaps at random places, then light can seep outside and we get a space colony that can last for trillions of years. That's how we capture
What's a
that
space colony?
Earth, but not on Earth. Basically, a house in space. Let's just leave it at that.
Okay.
Do you know what the International Space Station is?
Yeah.
Now just think of another one orbiting a different planet, or another or something like that on another planet, and that's a space colony.
Okay.
It's just basically a place where humanity can live that isn't Earth.
Yeah, okay.
But yeah, this is how we capture the energy of a black hole. If you have gaps in this mirror, then you can build a space colony. If you don't, well, just say bye-bye. You've automatically killed yourself, to put it simply. Now then, before we go on, is there anything anyone wants me to repeat? Hello? Is there anything anyone wants me to repeat? Unmute yourselves and just ask me any questions.
No, no doubt.
No.
Well then, let's begin. Why do black holes spin? Private chat answer. Question 2. When a spinning object gets smaller, what happens to its rate of spin? Private chat answer. Yes, you're all right. They spin faster. Question 3. What do spinning black holes have instead of a singularity, and what are the properties of this thing? Private chat answer. You need to get both correct this is a 2-mark question. So yeah, time is up. This is what I was looking for. It's a ringularity, or as Parnika said, a ring singularity with no surface or thickness, but the shape of a ring. That's what I meant by properties. As in like what it is. And when you describe it, you have to mention that it doesn't have a surface or a thickness, but it's in the shape of a ring.
Yeah.
You have to mention that. What is the new region of reality or spacetime created around the black hole? Yeah, it's C, the ergosphere. Don't worry about all this confusing nonsense here. You don't need to know that. All you need to know is that this is the ergosphere. Job done. How fast do you need to be going in order to stand still in the ergosphere? True. Yeah, you have to go faster than light speed or the speed of light, which, as Ditya said, is completely impossible. End. What are the 2 forms of energy we can steal from a black hole, a spinning one? Yeah, you get light energy and kinetic energy. What is the name of the process with which we steal kinetic energy from a spinning black hole, and how do you do it? Private chat answer.
Part.
Okay, so it's called the Penrose process, which all three of you got correct. You enter the ergosphere in the direction it spins, take its kinetic energy, eject some mass into the black hole to escape the ergosphere.
So I'm gonna get like 1 mark.
You're only getting 1 mark.
Okay.
Question 8.
Well, I didn't say exactly what you said, but
It's okay.
is
You got
this okay?
the idea correct. Anyway, question 8. How do we make use of the Penrose process? The answer is B, interstellar travel or traveling between the stars. How do we build the bomb? Private chat answer.
Like the full process?
Not the full process as to how the bomb will explode, but how do we build it?
Okay,
Just
so
what is the structure we need? That correct as well. All three of you got it correct. Surround the black hole and the ergosphere with mirrors and fire a beam of microwaves into the structure. There was a bit of a typo here, sorry. What is the name of the phenomenon that occurs when the microwaves bounce around the structure on the inside and gain energy? I need the name, not what happens. The name. Super radiant scattering.
1 minute. Let me see what I went wrong.
You used 2 P's, not 2 R's. That's what you did wrong.
Oh yeah, sorry.
It was close enough. You get the mark.
Thank you.
Question 11. How is it a bomb? But yeah, the energy inside will build up and it will result in an explosion if it's not let out. Like Veronica says, it will tear apart the structure apart. What is the other
Was
use?
this a 2 mark question?
No, it's just that Veronica went above and beyond.
Okay.
But this is a pretty easy one. What is the other use of this superstructure? The answer is A. It will be a space colony in the far future. Now then, I think it's time to reveal who got the best score. Everyone's videos are on. Nishka, I cannot see you.
Can you see me now?
Yeah, I don't know what happened there, but anyway. So, the winner is Nishka.
Thank you.
You got all the marks. You got all of them correct. Ditya, you came second, and Barnika, you came third. But either way, well done, all three of you.
Thank you.
This was a very hard subject, and I'm honestly impressed you guys got that many questions correct. Now then, just before we end this class, is there anything you guys want me to go over? Just anything?
No, I'm good.
Ditya?
No.
Barnika?
No.
Okay.
How many marks did I get?
You got 12, but since there were a couple 2 markers, let me just count the total number of marks. 1, 2.
How many
There were
questions were there in
14.
the quiz?
There were 12, but there were 2 2-mark questions, so there were 14 marks total. Nishka, you got 14. Ditya, you got 13. Parnika, you got 12.
There was just 1 or 2 marks off me, and yeah.
Yeah. So either way, well done, all three of you. As far as I remember, this is. Oh yeah. I think some of you guys got some emails about sending some videos about your experience at quarantine learning.
Yeah.
Yeah, I did.
Yeah, we have to like record a 20-30-second video.
Yeah, just talk about like what. Just talk about like if you just like how much you like the class and like what it and like how it helped you. Okay. Like that's all you need to talk about. What else? Oh yeah, if there's any artwork you want to send in, you know the email to send it into.
Yeah, we do.
Remember to subscribe to the YouTube channel and look at any videos you missed.
Yeah,
And
I've subscribed already.
I think everyone has. Oh yeah, go ahead, Pranika.
So for like you were saying, like you have to record a video, right? Like to say like our experience and everything. We have to do it for every single like class, or can we like just do one
Just
video?
just generic for quarantine learning.
Oh,
You
okay.
don't
Yeah,
have to do
sure.
it for. You don't have to do it
Each
for
one.
however many classes you take. How many classes do you guys take actually?
I take all the classes except guitar and Python programming.
Well done.
I attend all the classes except for cooling.
I do all of them except for cubing, Python, and guitar. Because I don't have a guitar, I don't really know how to do cubing, and I'm not interested in Python's hard. So yeah.
Well, I mean, I have tried Python myself. It's not that hard. You just need to use your head. That's just something I'll say. Don't worry. And don't worry though. I'm very impressed with all three of you though.
Thank you.
Now, this is actually a little embarrassing, but I'm not sure what to do next week. I will give you guys some options. So do you want me to do the scale of the universe, just to give you an idea of just how big or how small we are? Galaxies or nebulas? Which one do you
Closer
want?
to the scale of the universe.
Scale of the
Thinking
universe,
about galaxies.
Galaxy is your vote, Barnica?
Anything is fine.
You have to choose one because there's one vote each. There's
Okay,
one vote for two
just
things.
say the scale of the universe, Parnika.
Okay, fine.
Okay, DJ, you're
Either way,
beaten.
all this will make you do is feel really tiny. So, scale of the universe it is. Either way, I think that should be the last call, so it would be a good way to end it off. But yeah, that should be everything. Yeah, let's